to the 10th tutorial session of our operation planning of power distribution system. Our instructor Professor Sanjeev Ganguly sir from IT Guwahati, and I'm Satya. I'm a PMRF research scholar at Department of Energy Science Engineering IT Bombay. So that I will solve few of the problem that will help you to solve the assignment, current assignment. So without wasting time, let's move further. So if you see the first problem, so this is question related to the distribution network reconfiguration. There are four options is given, like what are the benefits, what are the actually meaning of the reconfiguration. So you just see the statement which is already given. So tell me the which statement is actually correct and which is false. So let's me give the solution for this. So when you see the reconfiguration, so read the first statement. It's telling that reconfiguration means just changing the topology of the network. That is true, because you just need a certain switches in between to operate, and then you can change the topology of the network. Okay, so it can be done only through the manual switching operation, though that is false, because you can take the automatic switches also for this operation. So that is not specific to, because it's written here only. So you can use the automatic or you can use the manual switches also. Okay, during reconfiguration all demands should be made. So that is the primary objective basically. So whatever the source is there, whatever the p load is there, so the from the source in, okay, whatever the source is coming, so that should actually match with the load. Okay, so and also the losses. Okay, whatever the losses in between, so you have to, all things should come from the source side, so that will meet the load and the losses which is occurred in between. Okay, the radiality of the network should be maintained. Okay, so this problem, when you see it is a statement is also correct. So this is important because radial operation simplifies the protection, control, and the fault isolation. Okay, so the first statement, all four statement except all three statement except this second statement is actually correct. So 1, 3, 4. Okay, let's move further, try to solve this problem. Okay, let me give the solution. So when you see the following statement about the switching operation, so synchronizing switches are normally closed, tie line switches are normally open, reconfiguration is done by opening. So when you see the first statement that synchronizing switches are normally closed, that is true because these switches are the part of the main feeder path. So they are remain closed during the normal operation so that the power can flow to the connected loads. Okay. When you see the second statement, tie line switches are normally open, so that is also correct. These switches are kept open until the normal operating condition are used and during the reconfiguration to create an alternative path, okay, whenever required. When you read the third statement, it is saying reconfiguration is done by opening tie switches and closing synchronizing switches. That is actually incorrect. That reverse happens. So reconfiguration is performed by opening the synchronizing switches and closing the tie line switches. Okay. Whatever the fourth statement, switching can may be manual or automatic. That is true. Okay. So the first, second, and fourth statement is correct, and the third statement is false. Okay. Let's move further. Try to solve this problem. Okay, let me give the solution. So when you see the statement regarding the benefit of the optimal reconfiguration, so it reduces the volt power losses, it reduces the power losses. That is true. It improves the bus voltage. That is also true because when you have the reconfiguration can be so the voltages at some points can be improved. Okay. It improves the network reliability. That is also true when you isolate the faulty part and increases done a switching or reconfigure the network, so the all the demand will be made from the source side, so that is also a reliable operation. Okay, it decreases system security. That is false. Okay, so the first, second, third statement is true. This statement is incorrect because the optimal reconfiguration can increase the security, not reduce it. Okay, let's move further, try to solve this. Okay, let me give the solution. So when you see the statement, it is regarding the network configuration problem. So here there's some statement written what kind of problem it is. Okay, so it is an optimization problem. That is true because you have to meet all the source and demand and considering the losses to be less. It is either single objective or multi objective. So that is also true. It can be both. Okay, and either of them, and single also, the multi also, its solution space is extremely small, though that is false. It can be there ki, when you see the solution space, in reality the problem is extremely large communication of solution space will be there, so large number of switching combination are possible in that scenario. Okay, so when you see the fast loss estimation is important because many configuration must be evaluated repeatedly. So that is correct. Okay. So if the loss calculation is slow, so overall reconfiguration method becomes computationally inefficient. Okay. So statement 1, 2, and 4 is correct. So this. Let's move further. Try to solve this. Okay, let me give the solution. So when you see the motivation regarding the reconfiguration research, so going penetration of DERs is also one of the motivation. Modern flight devices, that is also correct. Advanced information communication technologies, that is also correct. Reconfiguration has nothing to do with the stochastic, that is false, because the stochastic is one of the information when you see here. So the reconfiguration research is related to uncertainty stochastic operation, so it is not independent of it. Okay, so the first, second, and third statement is correct. Okay, fourth is false. Okay, let's move further, try to see this. Okay, let me give the solution for this. So when you see the statement, they are talking about the optimization objective in the reconfiguration. So that is first statement is that it have to maximize the restoration. Okay, so that the all the supplies, all the demands should be met. Energy loss minimization, that is also true because you have to reduce the I score or losses in between. Feeder or the transformer load balancing. So when you talk about this is also correct because it's help in distributing the load more evenly across the feeder and transformer, reducing the overloading risk and improving the system performance. Okay. When you see the fourth statement, it is the intentional increase of the switching cost. So that is false. We don't want to increase the intentionally the switching cost. Okay, so it's the objective is to minimize the switching cost and also to reduce the number of switching or operations, not increase it. Okay, so the first, second, third statement is actually correct. Okay, let's move further. So when you see this problem, this is talking about the what are the constant in the reconfiguration. Okay, so when you talk about the this constant of this, so this is power balance is also one of the constant, bus voltage limit, thermal limit, and radiality. Okay, so when you talk about why the first statement that power balance would be there, so it is essential constant because the total power supplied by the source must meet the total load demand and system loss. So any feasible reconfiguration must satisfy this balance operation, and also the bus voltage limit. So this is also an important constraint. So magnitude at each bus must remain within the prescribed allowable limit so that the consumer receive acceptable quality of the supply. Okay. When you talk about the third statement, it is stating the thermal limit, so mean the current flowing through the each line should not exceed its safe covering capacity. Otherwise, the conduct, the overload, and the reliability must be affected. Okay. When you talk about the fourth statement, it is talking about radiality is one of the important constant in the distributed network configuration. Okay, so even after changing the switch positions, the final structure of the network should remain radial to ensure the simple protection and the coordination reliable operation. Okay, so the all statement is correct. So the option is C. Okay, let's move further. Try to solve this. Okay, let me give the solution. So, in this problem, it is talking about the statement regarding the single objective reconfiguration example. So, when you have the single objective, so it means that either it could be increasing the reliability or reducing the power losses. So, that can be one single objective. So, if you're talking about minimization of energy loss, so this is a single objective problem. That is true. Minimization of financial losses due to voltage sag is a single objective. That is also true because you are optimizing this objective, consider the economic impact. Okay, so that is also the correct statement. Minimization of power losses together with safety and a single objective, that is false because you are considering two objectives. One first is to reduce the I square R losses, and also second you are taking about the reliability terms. Okay, so that's why this statement is incorrect. What about the fourth statement talking about current resistant branch status appears in the energy loss? That is true because it depend upon the I also, the R also, and the how actually the length is there. Okay, so that's why the variation should be on the branch status as well. Okay, so in this the one, two, four statements correct. So option B is actually correct. Okay, let's move further. Try to solve this. Okay, let me give the solution. So, in this problem, it is saying what is the statement about the multi-objective configuration. So, power loss can be minimized along with the worst voltage drop. Okay, that is true. When you talk about the multi-objective, so it can use the two parameters to be optimized. Okay, this shows the problem does not focus on the one technical parameter but try to improve more than one performance measures. Okay, so that's why it is correct. So when you talk about the second statement, Safi and Daffy can appear in the objective function. That is true because you when you are increasing the reliability of the system. Average services ability index can be included. That is also true because it shows that the service quality and continuity can be optimized along with the electrical parameter measure. Okay. When you talk about fourth statement, it is talking about multi-objective reconfiguration ignores the interrupted customers. So that is also that is false because you have to consider the interrupted customers into the system means optimization. Okay, let's move further. Try to solve this problem. Okay, let me give the solution. So when you see about the multi-objective approaches, so in that scenario, the weighted average is being used. That is correct because in this method, different objective can be confined into the single function using the weighted factor. Okay, so the first statement is correct. Second is talking about the fuzzy multi-objective approach. Okay, so when you talk about this approach, this is useful for several objectives to be considered together, and soft limits are preferred instead of the strict hard limits. Okay. Second statement is also true. Third statement talking about Pareto-based approach. So in this, though, basically Pareto-based multi-objective approach is another method for reconfiguration. So it is especially suitable when the objectives are conflicting and set of trade-off solutions is required. Okay, so that's why the statement 3 is also correct. Statement 4 is talking about one of these approaches applicable to reconfiguration. Okay, only it is talking about, so that is false because you can use the multiple. It's not about the one of these approaches applicable. So multi method can be applicable into that. Okay, let's move further. Try to solve this. Okay, let me give the solution. So this statement is talking about the Pareto-based multi-optimization objective optimization. So when you talk about this kind of optimization, so this is basically it is useful for the objective when are conflicting in nature. Okay, so in the distributed network, when you have the objectives such as cost, reliability, and the power quality, they may not improve together in the same direction. So that's why we use the some this methodology to have certain conflicting nature in between. Okay, so, and the statement two, when you see the better value for all optimization may not exist simultaneously, that is also true. That's why the no certificate state that better values of all individual objective does not exist in the same direction. Non-dominated solutions are preferred. So, in this solution, so no other solution is better when the all objective at the same time. Okay, set of such trade-off solution is called as Pareto front. That is true because when you having the collection of these best trade-off solutions, so instead of producing only one answer, so multiple solution can be given for the planner in which direction the its optimization with the better constant which it wants, so it can move in that direction. Okay, let's move further. Try to solve this problem. Okay, let me give the solution. So when you talk about what is considering the classification of the reconfiguration method, so either heuristic method, meta heuristic, or mathematical, so all statement is actually correct. So you can use any of the automation method. Okay, let's move further. Try to solve this. Okay, let me give this. When you see about the statement, it is talking about the basic reconfiguration algorithm. So the first statement is telling about the in the basic reconfiguration algorithm. So first closed switches were first closed to form a mesh network. So that is when you talk about the this step is important because it creates the possibility of the alternative paths. Okay, that can be later be examined for the selecting the better network configuration. Okay, when you talk about second, the load are converted to loader current injection before running the power flow. That is basic power flow equation, a rule to converting from the current based sources. Okay, so switching carrying the lowest current is open first based upon the optimal flow pattern. That is also correct because this is done to process for restoring a radial configuration while aiming the improved operating performance. Okay, when you talk about the constant checking is unnecessary, that is false. Constraint is very very important, so you have to consider that. Okay, any violation in the algorithm repeated the switching process until an acceptable configuration is obtained. Okay,